Remember that solubility equilibria are conventionally written with the solid on the left-hand side, then the equilibrium arrow, and then the ions on the right-hand side. And then the KSP values that are listed in tables or given in papers or in questions are written in that kind of context, where the equations are always solid going to ions. So, with a situation like this, you can have three types of Q values, three types of reaction quotient. You can have situations where Q is larger than K, equal to K, or less than K. If Q is larger than K, it means you have relatively more ions than you need to have equilibrium conditions. The reaction is going to shift away from the ions and towards the solid. And that means you're going to have a precipitation occur. If Q is exactly equal to K, then you're at equilibrium. And when your Q is equal to K, the solution is said to be saturated with the solid. That is, the maximum amount of solid has dissolved. And if you add any more of that solid, it won't dissolve and it will remain as the solid material. The final condition is when Q is less than K. And when Q is less than K, there are not enough ions to reach equilibrium, so some more solid is going to have to dissolve and dissociate. And we can apply this concept really simply to answer straightforward questions like, if we mix these two solutions, will something precipitate? So a very straightforward question of this type is, if you have a liter of 0.001 molar lead nitrate, and you mix it with 1 liter of 0.002 molar sodium chloride, will any lead chloride precipitate? You'll need to have the lead chloride solubility equilibrium and the KSP in order to answer this question. The solubility equilibrium and the equilibrium expression are pretty easy to write, and we can look up the K value from the table at the back of your textbook. And then to answer the question, you simply need to find Q, which means you need the concentration of lead ions and chloride ions in solution. Remember that lead nitrate and sodium chloride are strong electrolytes, so we can very easily find the concentration of lead ions and chloride ions. Before mixing, you have 0.001 molar lead ions and 0.002 molar chloride ions. After mixing, they'll both be diluted from 1 liter to 2 liters. Once we have their diluted concentrations, we can enter them into the Q expression. And we have a situation where Q is considerably less than K, and therefore no precipitation occurs. We can also ask more interesting, complicated questions like, if you mix two solutions, which one of the solids precipitates first? You can have solutions that have more than one metal ion, and if you add an ion that will cause a precipitate, so in this case, if you add a chloride ion to lead ions, silver ions, and mercury ions, you can make potentially 3 different solids. And we can determine not only which one will precipitate first, but the order in which they will precipitate. To start with, we need the equilibrium reactions, and more importantly, we need the KSP expressions that result from those. And again, if you need a K value, you can simply look them up. And it's really easy to figure out the order in which these will begin to precipitate. All you have to do is plug in the metal ion concentration to the K expression, and solve for the chloride ion concentration. And that'll give you the chloride ion concentration that's required to saturate the solution. And therefore any additional chloride ion would make Q bigger than K and start the precipitation of that solid.